Okay, we now cross on to our last example on parallel and perpendicular vectors. In our previous video, we looked at parallel and perpendicular vectors, where we said that a vector is considered to be perpendicular to another vector if their dot product is 0, simply because the angle between them is 90. And from our concept of dot product, if we dot A with B, we get magnitude of A magnitude of B cos of the angle, which if the angle is 90, the cos of 90 is 0, and that simply means that we shall end up having A dot B for perpendicular vectors being 0. So in our example here, they are telling us to find the value of lambda if lambda I plus 2j minus k and 5I minus lambda j plus 6k are perpendicular. I want to consider these two to be vectors A and B. I'm calling this one A. This first vector will be my vector A, and this one will be my vector B. So our vector A is equal to lambda I plus 2j minus k, whereas our vector B is equal to 5I minus lambda j plus 6k. They are telling us these two vectors are perpendicular. We can still write this one as lambda 2 negative 1, and then we can write this B as 5 negative lambda, and then we shall have our 6. So if A and B are perpendicular, if A is perpendicular to B, then we are saying our A dot B must equal to 0. So this simply implies I'm going to dot, I'll have my lambda 2 negative 1, dot it with 5 negative lambda 6, and equate this to 0. I'll end up having my 5 times lambda, which is 5 lambda, 2 times negative lambda minus 2 lambda, negative 1 times 6 minus 6, and this is 0. I'll end up having my 3 lambda minus 6 being 0, and therefore lambda becomes a 2. So that becomes our value for lambda. In part B, they are telling us to find a vector which is parallel to the resultant of the vectors above. In other words, we want the vector that is parallel to the sum of A and B. So we said if we are talking about parallel vectors, from the concept of parallel vectors, we said any two vectors are considered to be parallel if their unit vector is the same. So from there, I want the resultant of the two vectors. Let my resultant be C. Let the resultant be C. So to get the resultant, we said we simply add A plus B, and we shall have our resultant of these two. A is lambda, but our lambda is a 2, and then we have our 2 negative 1 plus our B, which we have as 5 negative lambda, which will be negative 2, 6. We end up having the resultant as 7, 0, 5. So that is it. We are now going ahead to look for a vector which is parallel to the resultant of the vectors above. I want to let this vector be D. Let the vector be D. They are telling us find a vector which is parallel to the resultant. Our resultant is C. We are first getting the resultant, which is C, of the vectors above, and has magnitude root 148. So this question is the same as telling you to find a vector which is parallel to A plus B of the vector above, which is parallel to A plus B and has magnitude root 148. So they are telling us we don't know D, but we know its magnitude of D is equal to the square root of 148. We are saying we want it to be parallel to C, which C we have got as 705, and we can get the magnitude of C as the square root of 7 squared plus 0 squared plus 5 squared, giving us the square root of 49 plus 25, which is 74. So we said from our concept of unity vectors, if any two vectors are parallel, if D is parallel to C, then my D cap, which is the unity vector of D, will equal to C cap. So my D is going to be, D cap will be D all over the magnitude of D, which is root 148, which will equal to C, which we know as 705, divided by the magnitude, which is the square root of 74. When you work out this, you'll end up having your D cross multiply root 148 into 705 all over the square root of 74. Now 148 is 74 times 2, so we shall have our D be equal to root 2 times root 74 all over root 74 into 705, giving us our D. We remain with root 2 times 7, we get 7 root 2, 0, and then 5 root 2. That becomes the vector which is parallel to the sum and has magnitude root 148. We now cross on to resolving forces or resolving vectors. We want to look at how do we resolve a vector. Okay, we now go to resolving vectors. We are saying resolving a vector is done when given a vector with known magnitude and angle of inclination. So sometimes we are going to be given a vector, but we only know the magnitude and the angle to which it is acting. So we are saying resolving a vector means to split the vector into perpendicular components. For example, given vector Q with magnitude 5 units inclined at 60 degrees to the horizontal, resolve Q and express it in the form AI plus BJ. So I'm going to assume that if this is my Cartesian plane, this is my y-axis, and this is my x-axis. There is a vector which I've been told looks like this, and they are telling me its magnitude. I'm assuming this is my vector Q, and the magnitude of Q is equal to 5 units. So it is acting at an angle of 60 degrees to the horizontal. So if this is my horizontal, this vector is acting at an angle of 60 degrees. We are saying to resolve a vector, we split it into perpendicular components. So I can create a perpendicular here like that to meet this horizontal at 90 degrees. And when you look at this, I've come up with a right angled triangle. If I call this my x and call this my y, from our knowledge of trigonometry, my sine of the 60 degrees will equal to y all over 5, because the magnitude now is 5 units and it is the hypotenuse. So y becomes 5 sine 60. Then if I look at the cosine of 60, it is going to equal to x all over 5. X becomes 5 cos 60. And now I have two components, y and x, and these two are meeting at 90. When you get these two components, we call them components of this vector of this vector of magnitude 5 units. That means you have resolved it, and now you can write Q as a vector, which we are saying it has its x and then y. The x coordinate is 5 cosine of 60, and then the y is 5 sine of 60, which you can write down. Cosine of 60 is a half, shall have 2.5. Sine of 60 is root 3 over 2, shall have 2.5 root 3. And therefore our vector Q has in its component, we can write it in as 2.5i plus 2.5 root 3j. and that is how we resolve a vector. It is as easy as that. So members, now we finally look at the summary of what we need to know in this topic of vectors. The first thing you learned it at O level, is algebra of vectors, which simply means addition, you subtract, multiplication, and then sometimes dividing. But multiplication and division is with a scalar or constant, with a scalar. So we go to magnitude of a vector, which we said if I have a vector A which is xy, the magnitude of A will simply equal to the square root of x squared plus y squared. So that is simply with magnitude. Unity vector, we have seen what it means to get a unity vector. It has magnitude 1, and we have seen how it is got. The common unity vectors are I, j, and k, which are simply unity vectors. I is the vector in the x direction, j in the y, and k in the z. We have seen the resultant of vectors, which we have seen that it simply means adding vectors. We have looked at the dot product of vectors, which we have said if I have vector a and b, their dot product will be a times a dot b equals magnitude of a magnitude of b cosine of theta, and the dot product helps us to get the angle between vectors. We have gone ahead and looked at pi and perpendicular vectors in our previous videos, and we have seen what it means, how to get a vector pilot a given set of vectors, and finally we have now looked at how to resolve vectors. And if you know all this, you're a good student of vectors, and you can handle most or all the questions on vectors. Thank you for watching. Have a nice time.